Here we're going to go through some properties of exponents so we can simplify expressions. So what we'll do is look at the separate rules and then we'll start mixing them all together in the next video. So our basic form is we have a base and an exponent. So for this example, we would call 2 the base, and then our exponent would be an exponent of 5. Now, exponents shorten multiplication for us so that we don't have to write so much. So 2 to the 5th is the same thing as 2 times 2 times 2 times 2 times 2. I think I said too many 2's there, but 5 2's multiplying together, but we can shorten that with 2 to the 5th power. Now, our product rule says if we are multiplying two values with the same base, we can add the exponents. So for example, if we have x cubed times x squared, what we could do is add those exponents of 3 plus 2 so that we'd have x to the 5th. And just to see a breakdown of that, if we have x cubed times x squared, that would be the same thing as x times x times x, so 3 x's, and then multiplying with x squared, which is x times x. So really this is just multiplying x with itself 5 times. What we could do is shorten that by thinking of addition of our exponents. Our quotient rule says if we are dividing two values that have the same base, we can subtract the exponents, and it always goes numerator minus denominator. So if I have x to the 5th divided by x cubed, we could combine that into x raised to the 5 minus 3 power, which would simplify to x squared. So just to show you why this works, x to the 5th over x cubed, that's the same thing as 5x's multiplying together divided by 3x's multiplying together. And what ends up happening is a cancellation. So that's what's reducing the number of x's we have, so that's why we subtract. So we'd cancel 1, cancel 2, cancel 3, so we could see we just have 2 left over. So whatever we have in the numerator, we're taking away the amount in the denominator. Okay, so let's try this out. So here I have r to the 23rd times r to the 15th. First thing I need to make note of is that they have the same base, and because they have the same base of r, I can combine them into a single expression of r by adding those exponents together. So I have 23 of them times 15 of them, so altogether 23 plus 15, so we have r to the 38th power, and that would be our simplified expression. Here we are dividing. Again, same base of m is very important there, so we can combine this into a single expression with a base of m, and to do that we would need to take the number of the exponent in the numerator minus denominator. And then we would just simplify, so we have a base of m, 125 minus 15 for 110. Okay, this one mixes some rules, and what we're going to do is completely simplify the numerator, completely simplify the denominator first. So what I'm going to do is first I'm just going to focus on this x to the 32nd power times x to the 4th, and what I could do is combine that into a single expression by adding. And then we're going to be dividing by x to the 12th. So that'll be x to the 36th power over x to the 12th power. And now what we could do is combine across the division by subtracting those exponents. So 36 minus 12, and that will leave us with x to the 24th power. Okay, so there's our product and quotient rules. Let's go on ahead to our power rules and rule of 0. So our product rule says, in parentheses, if we have values multiplying together and those are being raised to the same exponent, that exponent will go to each factor that's in the parentheses. So for example, if we have 2y in parentheses being cubed, 2 is going to be cubed and y is going to be cubed. So altogether we would have 8y cubed. And just to show you why that works, if I have 2y in parentheses being cubed, that would be the same thing as 2y times 2y times 2y. So that exponent of 3 is affecting each piece that showed up in the parentheses there that was multiplying. Now, the multiplication piece is very important. It has to be multiplication. If you see addition or subtraction, be very careful. We have different rules for that, which we'll talk about when we go to operations with polynomials. But with multiplication, we can have that exponent go to each piece. Quotient to a power rule. So if we are dividing two values and we're raising it to an exponent, each piece, the numerator and the denominator is each going to get that same exponent. So if we have x divided by 4 and that's being squared, we would have x squared over 4 squared, which would be x squared over 16. And just to show you why that works, I like to show this why it works, not necessarily to prove it, but so that if you don't remember the exact rules, you can always just write it out in this long form. And what you could kind of see is how the rule comes together. So like this, we'd have x over 4 divided, or multiplying with x over 4, and that gives us our x squared over 4 times 4, which is 16. So if you can't remember the rules, you can start expanding it out and seeing how those numbers combine together. Power to a power rule. So if x is being raised to a power of m, and altogether that's being raised to a power of n, then what we do is we multiply those exponents. So if I have x raised to a power of 4 and I'm raising all of that to a power of 3, I would multiply those exponents of 4 times 3, and we would have x to the 12th. And to show you why that works, if we have x to the 4th to the power of 3, that would be like having x to the 4th times x to the 4th times x to the 4th, which would be the same as x to the 4 plus 4 plus 4, which is our x to the 12th power. Okay, our power of 0 rule. Anything raised to a power of 0 turns into 1. And what's going to be very important, and this is actually important with all of these rules that we've been talking about, but especially with this one, we need to make sure we're applying the exponent to what's closest. So like in this case, just x is being raised to the power of 0, so all of that turns into a 1. So it's like all of that turns into a 1. Here, if I have 5 times x to the 0 power, well, that multiplication is separating things, so really it's just the x that's being raised to the 0 power. So that piece will turn into a 1, where 5 just remains the same. So we'd have 5 times 1 equals 5. Say we have some things grouped in parentheses, so let's say we have 2x cubed, y squared, z, all raised to the power of 0. Well, with parentheses, everything is being raised to a power of 0, so all of that turns just into a positive 1. So it all wipes out to leave us with a 1. Okay, so let's try out these rules with some examples here. So x times y being raised to the 5th power, so that means that exponent of 5 is going to go into each factor in the parentheses. So x is going to be raised to the 5th power, y is going to be raised to the 5th power. A over b raised to the 8th power, well, that's going to go to the numerator, and it's going to go to the denominator. So with that, we'll have a to the 8th power divided by b to the 8th power. Power to a power rule, I like to kind of highlight those together. So power to a power, we multiply. So this would be x to the 5 times 10, which would be x to the 50th power. All right, there's some examples with our rules. Let's look at some more here. 32, and what can help is kind of writing our multiplication so you can see how these are separate. And what's being raised to the 0 power is just the x. So 32 stays put, x to the 0 turns into a 1 that's going to be multiplying, and then we have our y cubed. So that's going to be 32 times y cubed. Okay, for this one, we have -2 times x squared times y to the 7th, and we're going to have that exponent of 2 go to each factor here. And parentheses will be very helpful here. So it's like we have -2 as a factor, that's being squared. We have x squared, that's all being squared. And then we have y to the 7th, and that's being squared. So we have a lot of power to a power rule here. So we have some power to a power. -2 quantity squared, so -2 times -2 is a +4. And then x to the, and we multiply, 2 times 2, which is 4. And y to the 7 times 2, which is 14. All right, good mixture here. What I'm going to do first is completely simplify the numerator, completely simplify the denominator. So before I use that exponent of 3 on the outside, I'm looking inside here. So that exponent of 0 is just on that 3 right there. So what I'm going to do is rewrite this, where that just turns into a 1 times, and then y to the 4th times y to the 5th. I can combine those by adding the exponents. All over 6y squared, and we will be cubing everything. So that'll be y to the 9th over 6y squared, and that's all being cubed. And one more thing that I want to simplify before I do the exponent of, I somehow changed that to a 2, that should be a 3, is to simplify that we have y to the 9th in the numerator, y squared in the denominator. Again, if it helps, you can keep drawing that multiplication symbol to show how 6 is separate from the y squared. So 6 is going to stay put in the denominator, but then for y, that'll go up to the numerator, and we'll have a 9 minus 2, which is 7. So that 7 came from 9 minus 2, subtracting those exponents following our quotient rule. And now I'm going to have that exponent of 3 go to the numerator and denominator here. So that's going to be y to the 7th cubed over 6 cubed, which is going to be y to the 21st power by multiplying those. And then 6 cubed, we could plug into the calculator real quick. 6 raised to a power of 3 is going to be 216. And I'm going to go ahead and pause there since that's a good length for a video, and I'll go on to negative exponents and combining kind of mixed expressions, mashing all of these rules together to simplify expressions.